Indeed, thank you very much, and thank you for the intro. Let me get this the right way round. It's an hour and a half, right, we got?
3 hours.
3 hours, fine, yeah. Okay, cool. Perfect. Welcome, everyone. I was going to put a big klaxon on, woo, to wake you up after lunch, because this is obviously the slot that people tend to be sort of a bit tired on. So hopefully I'll be able to stir you out of your stupor. Hopefully my jet lag will allow me to keep awake as well. I'm going to talk about, as Paul was saying, about software architecture, team topologies, and complexity science, and how a bunch of things I've been thinking about over the last 10 years, I think, fit together into some form of underlying set of principles for why certain sets of things that we do work. So, as just mentioned, some time ago, back in 2014, Martin Fowler and myself wrote what became a sort of working definition of microservices, if you like. But in that we said we cannot say there is a formal definition of the microservices architectural style. And the reason we said that is because what we were exploring in that article is stuff that was working, that we were seeing working out in the wild. Subsequently, it's gone on to sort of eat the world in some senses, the microservices style of architecture, for better or for worse. Incidentally, Elon Musk, turns out, doesn't like microservices. Apparently, he's been tweeting quite a lot about that. Microservices. And interestingly, Thoughtworks, who I work for, who we published the Thoughtworks Technology Radar, we've never actually had microservices in adopt on the Thoughtworks Tech Radar. Because if you're in Birgitte's talk earlier, everything is a trade-off, right? And nothing is always right in every circumstance. But saying that, when Martin and I put our paper together, we talked about this set of characteristics. Stuff that we were seeing that people were doing in the wild, in action, that was making them successful. All sorts of different companies, so publishing companies, trading companies, retailers, turns out streaming companies as well. Lots of these different companies all using these set of, which had these set of characteristics we thought in common. And over the last sort of decade, I've been thinking about why. What is it about this set of characteristics that's interesting? And specifically, more so about what is it about decentralization? What is it about pushing decision-making down to the people who know the most? What is it about the componentization aspects, the sort of cohesion aspects? What is it around this idea of organization around business capabilities and product, not projects? That seems to be at the heart of what we're talking about when we talk about microservices. But first of all, I'm going to start by talking a bit about something else, this idea of flow, value, and teams. Now, I was very lucky. I was at a conference, a sort of symposium, if you like, some time ago, with someone from Amazon. And that person from Amazon, they said this. The funny thing about Amazon, in particular AWS, is the bigger we get, the easier it becomes to get bigger. The more teams we add, the more products we build, the more features we add to those products, the easier it is to add more features, to add more teams, and to go faster. And that seems like a really strange or odd thing for me, right? Because my experience is the opposite of that, and we'll come to that in a second. Which, after thinking about this for a while, and this idea of, as we grow, we get to go faster, I sort of started thinking about what the goal is of organizational design. When we think about our software architectures, building software systems and linking them together to serve our customers, and the teams that go together to do that, to deliver deliver that software. What is the goal of those teams? And I've sort of come to think that it's this. The goal of successful organizational design, and therefore a successful software architecture, really, is to optimize value flow, right? It's to optimize the delivery of value from the ideas of the people who are holding the ideas through to the customers, the people using our software. Or to quote Daniel Tilhurst North, I like this idea, the goal of successful organizational design and team structure, and therefore software architecture, is to safely and sustainably reduce the lead time to thank you. But what do we mean? What do I mean when I say value? If it's all about delivering value to people, what does that mean? What is value? Well, I think of value, this is a technical definition of value, clearly. Stuff. Value is stuff. What is stuff? Well, stuff could be physical stuff, right? It could be clothes delivered to a retailer via a supply chain system or by warehousing, fulfillment systems. It could be movies streamed into your home or to your phones. It could be informational or it could be physical, but it's pretty much just stuff at the end of the day. If you squint, informational or not the product of knowledge work, if you like, and physical stuff is pretty much the same. It's just a set of things that go through a series of activities, a series of processes, accruing more value as they go. So if you think about a factory or a supply chain, you have some raw materials which get turned by machines into widgets, and those widgets get turned into more valuable widgets. And then finally, those more valuable widgets get turned into a car, and the customer buys the car. Well, similarly with what we do in things like the software delivery supply chain, software delivery life cycles, this is the same sort of process, right? We go through a series of activities where something of less value, like an idea, gets turned into something of more value. Maybe that's a set of requirements, and then it's turned into designs, or it's turned into code, and then tested code, and finally something that's put into production, and hopefully the customer says, thank you for it. Essentially what we're talking about is going from raw materials to a thing, right? That's what I think about as value. The valuable thing is the thing in the hands of the end customer, whether that's physical or informational. But my question here is generally how long does stuff take to do? Going back to that quote, the easier it becomes to get bigger. The easier, as we get bigger, the faster we go. Now in general, my experience is things tend to take a fairly long time. And as companies get bigger, and as companies get older, and AWS and Amazon are big and fairly old now, things tend to slow down. Now this is an example of a value stream from a previous client of mine, of Thoughtworks in the UK. And this is a slice, if you like, through their software delivery lifecycle. We start at this end with requirements or ideas, if you like, and then they accrue value by going through all this. At least there's kind of, there's business cases being built and options generated and designs evolved, and then stuff happens over here. I'm not sure. Well, actually, these two boxes, these are two different sets of enterprise integration architects who've each got a canonical model, and they go around in circles updating their canonical models for a bit in isolation from everything else. And then finally, if I got a laser, is that a laser? Oh, maybe that's not the laser. That's blue bit there. That's writing code. One sticky on that, writing code, and then finally we go into testing and more testing and more testing and more testing and so on. What this sort of demonstrates for me is the sort of, and this is by no means a unique example of this sort of value stream or value chain. This is the sort of thing you'd expect to see in big, old organizations. So what is it about AWS then that allows them to go faster to avoid this trap? And that's what the rest of this talk is about, both in terms of the way they've built their software architecture, and other companies have done as well, the way they've structured their organization in order to deliver, and to avoid the trap of months and months and months and months and months of updating each other's canonical data models. By the way, you might have noticed they've got two canonical data models. I'm not sure if they kind of understand what the definition of canonical is, but it doesn't involve plural usually, I think, in general. So, back to this symposium I was at. And this photo has been put in at the request of one of the speakers at YOW. So this is myself at this symposium with Adrian Cockcroft, who's here and speaking later. And this, ladies and gentlemen, is Melvin Conway. This is Conway of Conway's Law fame. He actually exists. He's a real person. He's actually one of the loveliest people I've ever met in my life. He's a true gentleman. But at this symposium, we were talking about we were talking about the uses we'd put Conway's Law to in an open space session. So we were talking about how we've structured teams according to Conway's Law, how we've organized software development life cycles, how the software architectures have looked as a result of that. And one of those examples was from, surprise, surprise, Adrian Cockcroft, former Netflix, was from Netflix. I'm stealing his thunder here. Adrian was talking about how at Netflix they organized their teams such that the people who needed to speak to one another sat next to one another, right? And how the people who didn't need to speak to one another sat miles away. So if you're working on the user experience for the Xbox, you didn't really need to speak to the people from the Cassandra teams, right? So they sat a very different part of the physical building than the teams doing that. But if you needed to talk to the platform API team, you were sitting close to them. So the people you needed to speak to on a regular basis, you were close to. So you maximized the amount of communication between those two groups. And that's really what Conway's Law is about. It's about information theory, about the information flow and the bandwidth, the amount of information between different parts of the organization, leading to different styles of architecture. Now, this is a slide I took a quick picture of from Dave's keynote yesterday. And I believe I didn't get the exact Kent Beck quote because I wasn't quick enough. But this is about Kent Beck talking about modularity and cohesion. Things that aren't related should be further apart, whereas things that are related should be closer together, modularity and cohesion. And this is what we're talking about with Conway's Law here, right? The teams that are related should be closer together, and the teams that aren't, and the software that they're building that aren't, are further apart. What does that do? Well, that gives us the opportunity to maximize the idea of flow, right? Maximize the flow of information between the two different teams or between the different parts of the organization, and minimize the flow between parts of the organization that don't need to talk to one another. Which brings me to this book, Team Topologies. I'm sure it's already been mentioned in pretty much every session so far. It's a bit like if you go to an Agile conference, everyone has to say Knevin. In a software architecture or software conference, everyone has to say Team Topologies, so Team Topologies. If you haven't come across this book, I heartily recommend getting it. I think it's one of the most important things that's been written in probably the last 15 or 20 years about what we do, about how we structure ourselves. Because what it gives us, much like the Blue Book, the Domain-Driven Design book by Eric Evans, it gives us a ubiquitous language to talk about the teams that we're building in our organizations, and therefore the software that those teams are going to be delivering. It gives us the ability to communicate more effectively about what we're trying to achieve when we're putting together different team structures. Anna last night introduced the different types of teams, so she talked about platform teams. So a platform team is a team that's building tooling that's making the rest of the organization go faster. So if you like, if other teams are about delivering value faster, then the platform team is about increasing the rate at which that value can be delivered for the other teams. You then have enabling teams, complicated subsystem teams, and so on. But all of this within the context of how we structure according to Conway's Law, according to the business, right? So you have these four fundamental topologies based around delivering value to an end customer. And going back a little way to the original Jeff Bezos memo back in 2004, which changed the way Amazon worked. Jeff Bezos, in one of the points in that memo, he talked about how each team should have a direct line of sight to a customer, to the customer. And that's really what these value stream-aligned teams are about. The stream-aligned teams are about having a line of sight to the people who are using your stuff. Because then you can optimize for delivering that stuff. Right. Back to the curious case of Amazon. The bigger we get, the easier it becomes to get bigger. Now, looking at that value stream, right, that's a big old company. They do things really, really slowly. And the late, unfortunately, recently late, great Fred Brooks, famously in the Mythical Man Month said, adding manpower to a late software project makes it later. And this is certainly received wisdom, right? You can add more people to a point, right? And at a certain point, you don't get an increase in productivity. You don't get any more value out as you add more people. And the reason is because the communication overhead of adding more people and those people the coordination cost becomes greater than the ability to go faster. And this, in my mind, is a sort of truism. This is received wisdom. We've got these value streams. That's why this thing is really slow. As you grow things, information overload increases to a point where you can't get any faster. So why is Amazon allegedly, AWS allegedly, able to go faster and faster and faster the bigger they get? So I went off and I had a look at some figures. Now, okay, there's some probably data people in the room, so apologies for this really rubbish graph. But what this shows on a really random set of axes as well is a log-log plot of Amazon revenue versus Amazon employee count. And this exponent there, 1.15, what that shows is as Amazon is doubling the number of employees it has, and this is including AWS, it's more than doubling its revenue. It's more than doubling the amount of money it's making, which seems to point in the direction, in the same direction. The bigger we get, the easier it gets to get bigger. The bigger we get, the easier it becomes to make more money. In fact, this exponent of 1.15 means that they're growing in advance of exponential. They're growing in a super exponential. Their revenue is growing super exponentially with respect to employee count. And that's not normal, ladies and gentlemen. That ain't normal. Which brings me to what I was saying at the start. What is it about certain characteristics of microservice architectures, but also information theory stuff, what is it about certain aspects of this that underpins some of these characteristics of microservices? And I've done a lot of research on this over the last 10 years or so. I've even been building simulators and models and all sorts of stuff to try and understand a bit more about complexity and how complexity and complexity science leads into the basis of what we do in terms of software architecture design and building teams and building optimal organizations. And a lot of that research that I've been looking at comes from this place, the Santa Fe Institute, which was founded in 60s, 70s, something like that, but by a guy pretty much called Murray Gell-Mann, who went on to win a Nobel Prize. And the Santa Fe Institute is one of the leading centers for studying complexity science and complex adaptive systems. Now here's a question. What do mice and elephants have in common? They have their blood pressure in common, would you believe? They also have the same rough number of heartbeats in their lifetime. We share a blood pressure with all mammals, right? All mammals have the same blood pressure, more or less, and the same number of heartbeats. But here's an interesting graph. This is showing basically metabolic rate versus mass. So as you double the size of a mammal, what happens to the metabolic rate? What happens to the amount of calories that a mammal has to take in as you double its size? As you double its size, you'd expect it to take, because actually, as you double the size of a thing, volume goes up by the cube, you'd expect to have to take in lots and lots more calories. In fact, you don't. As you double the size of an animal, you don't even you have to take in double the amount of calories. You only have to take in about 75% as you double the size of a mammal. Essentially what happens is, the thing that varies is the metabolic rate of bigger animals is slower than smaller animals. Their cells operate at a slower rate. The bigger the thing, the slower it gets. Elephants rarely, if ever, get cancer because their metabolic rate is so slow that their cells don't divide so many times, and so don't pick up so many genetic deviations, and so therefore don't end up getting cancer. That's the theory. Whereas mice, or the Etruscan shrew, which is about the size of my thumb, their metabolic rate is super quick, and they're just running around like crazy things. Metabolic rates in mammals follow this scaling law with an exponent of 3/4. So as a mammal doubles in size, it doesn't need so many calories. There's a similar straight line on the graph for companies. As you double the size of a company, this is data taken from the NASDAQ some time ago now, but as you double the size of a company, in general, you only get about 85% of the revenue. You don't get 100%, if you like. You get 85%. Revenue scales with number of employees following another scaling law. Similarly with cities, as you double the size of a city, you don't have to spend double the amount on infrastructure. Right? In fact, as you double the size of a city, you only need to spend about 85% on things like water pipes or things like petrol stations. You only need 85% of them. So infrastructure scales with population with this exponent. We have these strange straight lines, these strange scaling laws in all these things that are called complex adaptive systems. Geoffrey West, in the book Scale, which is a fantastic book, I recommend you going out and getting it, he says that quantities that do not change when other parameters of the system change, they play a special role in science. Pretty much what he's saying there is if you see straight lines in lots of different places, something's going on, and you should probably go and have a look. That's pretty much what he's saying. Play a special role in science. And what we're seeing in these different scaling laws is an example of something called linear scaling versus sublinear scaling. Ooh. So sublinear scaling is the effect that when you double one quantity, you don't double the other quantity, log-log. Linear scaling, when you plot it log-log, is exponential growth. Sublinear is sub-exponential growth. So complex adaptive systems, what are they? Well, they're everywhere, right? So we are complex adaptive systems. Companies are the teams we work in, the cities we live in. Life, essentially, complex adaptive systems. And they've displayed these 4 characteristics. They are self-similar. So, the cells in my body are self-similar to cells in a mouse's body. They display self-organization. Nothing tells my body really to turn into James, this particular James. It just self-organizes into it. They're complex, right? And they display emergent behavior. Right? The complexity thing, I like to think about the complexity part, is if you put James into a blender and blended me all up and poured me into a James-shaped mold, you wouldn't have James, right? You just have a bunch of goop, right? The whole is greater than the sum of the parts with these things. And the emergent behavior comes out because of that. Now, I talked about these scaling laws. Complexity, the complex adaptive systems and these scaling laws can be explained by 3 simple principles. The first one is networks, different types of networks. Sublinear scaling is always explained by having hierarchies present. Hierarchical networks leads to sublinear scaling, lead to scaling that is less than exponential. You also have to have something called invariant terminating units, or as my staffing function in Thoughtworks calls us, meat bags or something, people or cells in our bodies or houses in cities, and then some mechanism of optimization over time. I didn't start off as James, I started off as some kind of bacteria or amoeba-like thing in a pond billions of years ago, hundreds of millions of years ago. But suddenly I'm James many years later. So, evolution is acting as the optimization mechanism for life, but for companies and for cities, it's market forces, essentially. As I say, CASs, they're everywhere, and pretty much all these examples of interesting straight lines, scaling laws around metabolic rates, can be described by 3 simple principles, mathematically. And what that math shows is when you have hierarchical networks leads to scaling laws with power laws with an exponent less than 1. Basically, Walmart and a convenience store, they're the same, it's just they're just different sizes. Which brings me on to this question of slowness. Why? Why do metabolic rates different? Why does revenue growth slow as size increase? Why do metabolic rates in mammals slow as size increases? And it's literally down to the depth of the hierarchies in the networks that are present. Metabolic rate slows in bigger things because there's a deeper hierarchy of blood vessels. That's literally it. Well, there's some other details in the maths, but that's pretty much it. The deeper the hierarchy, the slower things go. And it's the same for companies. Bigger animals are more efficient, basically down to this depth of hierarchy in their circulatory systems, driven by feedback from evolution. But companies are more efficient as well. They display economies of scale for infrastructure as they scale, but they also develop a deeper hierarchies of information flow as they scale, and that leads to them slowing down. And that's been driven by market forces. Both slow down as they age. As companies age, their metabolic rate decreases. As mammals age, they do as well. Go back to flow. I mentioned value stream maps, right? You can think of a value stream map as a slice through the informational hierarchy of your organization. So the deeper the steps in that informational hierarchy, as I said, the deeper the hierarchy, the slower things get. Right? But it doesn't even, that's not even, I guess, the worst of it. So the more processes, the more activities you have to go through to deliver value, the slower things are going to be. But we also deliberately add steps into our processes that deliberately slow things down. Things like queuing states. Things like having to ask other teams to do work for us. We'll have to wait on integration with this other team. We have to put work into this queue over here. We have to put work into another queue to get a database instance, say. And of course, this is where Amazon or AWS totally changed the game, because they flipped the relationship between having to ask someone else to do something for you and you being able to do it yourself on your own by offering you self-service infrastructure. They removed a lot of the blockages from some of these processes of you getting stuff done. If you think about these sort of processes, they're the equivalent, when you have queues in a system, they're the equivalent of having plaque in your arteries. Right? You're narrowing the amount of information that can be flowing through the company, flowing through the value stream. But what AWS and self-service infrastructure does is removes those plaques, if you like. So back to corporate metabolism. As companies scale, they add more and more processes and hierarchy. And therefore, things slow down. With hierarchy, things get slower. It is inevitable. It's just maths. But we also deliberately block our corporate arteries by adding things like queues in, by adding things like change request boards, by adding things like architecture review boards, having to stop and wait for other people to do stuff for us. So the question is, can we identify the signs of aging? And I would argue that yes, we can. Right? I think we can identify in our organizations where we are, whether we're sort of relatively okay or whether we're kind of sick. So if you've come across this book, Accelerate, I know Dave was talking about DORA and the State of DevOps reports. Well, Accelerate, there's a summary of the State of DevOps reports over a number of years. Fun fact, in the State of DevOps reports and in Accelerate, the data points to the fact that change request boards are predictors of low organizational performance. I'm using that word precisely. It's not correlated with low organizational performance, but predict low organizational performance. And if you think about what I was saying earlier about value flow through teams, value flow, information flow through organizations, that should be pretty obvious. Every time you have to ask a change request board for a decision, and you have to wait there doing nothing, essentially you're blocking the corporate information arteries, if you like, the corporate value streams. You're putting back pressure up on the corporate circulatory system and on the corporate heart. Basically, change request boards are predictors of low performance because they put blockages in the way of information flow. That's not to say, I'm not saying we shouldn't have change request boards or architecture review boards, but we should be thinking really carefully about what their function is, things like how often they meet, and the effect on this information flow. So back to this idea of organizational health. So can we monitor organizational health and see how healthy our processes, our teams are, and the teams building our software architectures? Well, I think we can, and I think in Accelerate and the State of DevOps reports, they give us some pretty good ideas as to how. Mean time to recovery, cycle time, change failure rate, number of deploys, and in the last two, reliability. These are the equivalent of going to the doctors, general practitioners, GPs in the UK, and having your blood pressure taken, your heart rate measured, your temperature checked. These are essentially leading indicators of health. They're not going to tell you what's wrong, but they're going to tell you if you're really sick or not. And they'll also tell you whether you're getting better. So by monitoring these things, we can work out whether we're getting better or worse, whether we're feeling sicker or not. So using these metrics, we can identify the signs of aging. 4 key metrics are essentially leading indicators of organizational health. As I say, like monitoring heart rate and blood pressure and so on. But anytime we work to improve these, and we can work to improve these, example, change request boards again. If you have a change request board that meets once every month, and decisions are blocked for, on average, 14 days, say, right? That's the average cycle time for a decision to be made. If that change request board meets twice a month, suddenly you've doubled the cycle time. Sorry, halved the cycle time and doubled throughput, right? You're going to get better, you're moving in the right direction. But you can only get as good as the hierarchy in which you're working in and the hierarchy in which your team is working in. Hierarchies always lead to sublinear scaling. Organizational mortality. I promise it gets better and less depressing. There's an interesting fact, right? Larger organizations spend, turns out, the data shows that larger organizations spend less on research and development, right? And there's a direct analog with mammals aging here. So as mammals age, essentially, the more calories, or the higher proportion of the calories you take in, you have to use to repair your cells to stop yourself from aging. And eventually, over time, you're not able to repair them anymore, and you eventually die. And there's a direct analog with organizations. Over time, it seems that organizations, they spend less on the thing that that made them special in the first place. Less on new product development, less on research and development, less on the stuff that led to them being successful. And they spend more and more on just keeping the lights on, more and more on growth, more and more on infrastructure. And then it becomes about keeping costs down and all this kind of thing. But also, as organizations get older, they add more and more processes and constraints. They tend to add extra stages in these value chains, more levels in the informational hierarchy, in the organizational hierarchy. More hierarchy means things slowing down. And eventually, organizations die. Often, the half-life of a company on the exchanges, the listed company, is 10.5 years. 50% churn on the exchanges every 10.5 years. That's a pretty incredible statistic. Whether that's by acquisition by someone else, or whether that's merging, or whether that's by bankruptcy or whatever. But every 10.5 years, there's 50% churn on the exchanges. Essentially, hierarchies grow and grow, more processes and constraints are added, and the organizations spend less on the things that they were excited about to start with, product development, and eventually they die. So, I'm going to drive this home. Hierarchical organizations that have hierarchical information flows, they gain economies of scale for infrastructure. So this is a good thing. All right, so as you double the size of a company, you have to spend 85% of what you think you should on infrastructure, be that network cables, be that office space, be that light bulbs. That's a good thing. That is something that we should strive for, economies of scale. But also, because of the informational hierarchies in most big companies, because you have lots and lots and lots and lots and lots of steps and really, 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 really long value chains, they also achieve sublinear growth in revenue. So you get the same effect happening. And eventually they die. Brilliant. But there is something we can do about this, which is good, because there's another type of scaling law. And that type of scaling law is called returns to scale, rather than economies of scale. Or superlinear scaling. So superlinear scaling is when you double the one quantity, you get more than double the other one out, right? As opposed to sublinear scaling, which is where you double one quantity and you get less than double out. And for cities exhibit both types of scaling law. Right? So cities, for socioeconomic factors, as you double the size of a city, you get more than double the amount of innovation. You get more than double the wage growth, if you like. More than double the number of professionals. It's up to us to work out whether we want more than double the number of lawyers. Maybe that's moot, but you get more than double the number of professionals, as you would expect. But also some of the bad stuff, the negative stuff, more than double the amount of crime or pollution and so on. And also, you have to spend less on that infrastructure I was telling you about, so road length, petrol stations, and so on. So for socioeconomic factors, as you double the size of a city, you get more than double some stuff and less than double infrastructure. Incidentally, walking speed, if you've ever thought, as you go to a bigger town, people walk faster, they do. It's actually true. MIT did some research on this. They took a load of mobile phone data and sort of analysed it, and people do walk faster in bigger cities, which is interesting. So I'm looking forward to my robot legs, so I can just be sprinting around. What is it that's leading to these drivers? What is it that leads to superlinear growth in cities for socioeconomic effects? It's a different type of network. There are more than one type of network. We've talked so far about hierarchies and how hierarchies mathematically lead to these sublinear scaling, or economies of scale. Well, small world networks or social networks, they lead to this other type of scaling law, superlinear scaling. Much like you think about social networks, right? Social networks, that they are small world fractal space-filling networks. And these type of networks, these type of social networks, mathematically lead to superlinear growth. And it's related to something called Dunbar's number, which is interesting, right? So Dunbar's number is the number, you can think of it as the strength of the connections that you hold in your head at any one point. So there's a range of Dunbar's numbers. Most people think about the 150 Dunbar's number, which is the one that's most widely sort of quoted. But there's a number of these numbers. The first one is 5, and this is like your nuclear family, the strongest connections that you have, people who live in your house maybe. Which is awkward because I've got 4 children and a wife. So it actually means I either love one of my kids less or my wife, I'm not sure. Or maybe 2, I don't know, whatever. But then as you scale Dunbar's number, you end up with these sort of weaker and weaker and weaker connections, right? And this is what leads to superlinear growth in cities. Because people tend to associate in bigger towns, in cities, with people like themselves. Look at us in this room here today. People who've chosen professionally to go and learn from their peers in a conference, right? If you're in a really small town, tiny village, there might only be, however many people are in this room, 100 odd people. If you're in a town of 100 people, how many other software developers are there for you to learn from? Not that many. If you're in Brisbane, there's quite a few software developers for you to learn from and associate with and hang out with and form communities around. And that's what drives this superlinear growth in cities around innovation and things, is this fact that we can get together as groups, as communities, and share information and develop deeper bonds. So, as I said, sublinear scaling is driven by hierarchies. When you see hierarchies in organizations, where you see teams that look like hierarchies, you get sublinear growth. But when you are organized according to social networking principles, when you're organized around the strength of these connections between individuals, these small world networks, you see superlinear growth. Superlinear returns to scale, super exponential growth. I bet you, if you go to your CFO and say, hey, we can have super exponential growth, what do you reckon? I reckon they might be up for it. And the reason, one of the reasons cities are so successful and these social networks are so successful is because you can just bolt bits on the side, right? So you can have one part of a city, and then you can grow by adding another suburb, and you grow by adding another suburb, and grow by adding another suburb, and so on. And the city scales out like this. You don't have to kind of gut the whole thing in order to add more stuff into a city. Whereas in hierarchies, you have to really disrupt the hierarchy in order to grow. You either need to grow, you either need to deepen it, or you need to add more stuff on the side, which is going to increase the amount of information flow, increase the length of time it takes to communicate across the hierarchies, or for stuff to flow across the hierarchies. So as cities grow, they get the best of all worlds, right? They gain economies of scale for infrastructure, but they also gain returns to scale for socioeconomic factors. They rarely die. Basically, they get 115 more stuff for 85% of the cost as they double in size. 115% of the more stuff for 85% of the cost. Other companies that do this, right? So other companies that use these principles in order to scale both their teams and therefore the stuff that their teams are doing. Well, I would argue that Thoughtworks is one example. We've grown over the years. We actually had a principle that when we got to 200 in an office anywhere, we would start a new office. So that led to, in Bangalore, having more than one office, for example. Or we would often then start a new market. We'd move to a different city. So we've got many offices in Australia, many offices in Germany and so on. So we've tried to scale in this way by trying to scale by keeping the social connections between people as the important thing, right? Because that kind of optimizes the amount of information flow. You know, ideally what you want is to be working with a group of people and you know everyone's name. You know what their children do, if they have children. You know what their hobbies are like. That's the sort of place where you get to really experience this sort of high-performing organization. I would argue that the Spotify model of building software and of software architecture is also an example of trying to do this, trying to put a structure in place that says we're going to create social networks with just enough hierarchy to allow communication between them, right? With the different communities, guilds, chapters, and so on, providing just enough communication across the different tribes and across those squads within the tribes who are building the individual bits of software. Obviously, the Spotify model has evolved, but I think it's pretty much an example of this. Valve, the computer games company. Now, we've come across Valve, but probably about 10 years ago now, they accidentally leaked their employee handbook. And in their employee handbook, they had, this is how we want to grow and organize ourselves, and it's by social networks, it's by small world networks. They lay it out because this is how we go fast. This is how we get to go fast. And then back to Amazon. Now, you might notice 1.15, that's the same exponent as you would expect if you were growing super exponentially because of using small world network growth effects. So Amazon are kind of doing this as well, or AWS in particular. So how is it that Amazon got to this point where they're able to do this? Now, I've got theories, I don't know. I've talked to people about it. They seem to think I'm not completely bad. But if you think about how the journey that Amazon and then what became AWS have been on over a number of years, you can go back to sort of, again, 2004, this sort of memo, which sort of laid out a path to the future for the company, right? We're getting so big, we're slowing down, we can't go on anymore like this. We need to change the organization so for it to be fit for the future. Obviously, there was a thing about if you don't do what I say, you'll be fired, which doesn't work in Australian labour laws or European labour laws, but hey, US. What were those things that were put in this memo that sort of made Amazon what it is today and AWS what it is today? Well, I would argue things like teams must communicate via interfaces. I mean, this is very much a software architecture kind of principle, right? No more talking to each other's databases. We have to communicate via strict interfaces. All interfaces must be externalizable. I mean, you could argue that this principle or this idea led to AWS, right? With the idea that if we have an interface to the outside world, we should be able to sell essentially that interface. That should be something that we should be able to present to the outside world. And then two pizza Dunbar's number teams. Back to Dunbar's number again. And I would argue what these are is this thing like they're forcing functions for flow within the team structure of Amazon and AWS, within the team structure, I would argue, of Spotify, for using slightly different forcing functions, and Valve, and other companies who've adopted this type of social networking model. They're forcing functions for flow, limiting interaction to nearby teams. As we said at the start, and as Dave was talking about when he was quoting Kent Beck, cohesive teams that need to interact with those teams that they need to interact with. Team isolation, putting boundaries around things, putting boundaries around your teams, and Conway's law, around your software as well. And then scaling by this idea of Dunbar's number, so using social networks to drive growth. So as most companies get bigger, it gets harder to get bigger, but according to the numbers, as Amazon gets bigger, it is indeed getting easier to get bigger. And if you think about how AWS, the rate at which AWS is able to produce, put new products to market, essentially what they're doing is they're creating these decoupled teams and bolting them on, much like cities do. Onto the side, onto the side, onto the side. To the point where, if you've ever used a lot of Amazon, of AWS services, you'll notice that one set of products has got a completely separate API from another set of products. from a user experience perspective, as a developer using this stuff, it's awful, right? But they've optimized to scale the number of products they can add and the number of teams that they can create. And they've traded off user experience across those products as a result. You don't get everything for free. So I'll summarize. Going back, I've been thinking about this for a number of years now. I've done a bunch of research about why a lot of this stuff around decentralization, pushing stuff to the edges, microservices, encapsulation, organization around business concerns, products, long-lived products over projects and so on. Why does this work? Going back to team topologies, it's about this idea of maximizing flow, maximizing our team structures and the products that they're building in isolation for flow, for delivering value to our clients or the customers, until they say thank you. That should be what we're aiming for. And I'll leave you with this, which is that social networks imply super exponential growth. Hierarchies, when you have them, they slow metabolic rate. Think about team shapes for flow. Think about these value stream aligned teams with direct lines of sight to the customer, building products in isolation. But remember, you're going to have to trade stuff off if you do that. And this idea of forcing functions for flow, both in terms of our software architecture, the software we're building, how our teams interact, and how our organization is designed. This is the set of references that I've been relying on in this. There's a set of sort of summaries of a lot of the research. There's also a bunch of the original research underneath. Obviously, this will be available. I'll stand back. And I think, for me, that's the lot. So thank you very much for attending.
We've got time for maybe one or two questions. So does anybody have a question out there? Just come and meet me with the microphone.
This is where it gets a bit Benny Hill.
Given how effective this organisation is, why do you think so many organisations seem to gravitate towards hierarchical structures?
Good question. So the question is, given that this appears to be a really effective way of doing stuff, why is it that most organizations gravitate towards hierarchies? I think, A, because it's easier, and secondly, this is also a fairly new area of research, right? The study of complex adaptive systems and complexity science only goes back 20, 30, 40 years, you could argue. Maybe a another example would be in economics. If you're in Birgitte's talk, she talked about behavioral economics and the change away from the sort of static view of the world in economics to a slightly different view of the world, which is looking at behaviors and so on. There's another view of the world from complexity economics or non-equilibrium economics. That still hasn't taken off yet. I think it's just too new. I think people are stumbling across these ideas. And I think the science is pointing in that direction. But it takes time to change. It takes time, if you're a 150-year-old organization that's been organized in a particular way, it's very, very difficult to change that, right? What I have seen is successfully organizations taking parts of their business, big organizations, and experimenting with this sort of stuff. So whether that's the digital, it's maybe an anti-pattern, but the digital bit of the business, that is sort of organized slightly differently according to these sort of principles. But I think it's early. It's going to take a while for some of these ideas to bed in. I should also point out that Jeff Bezos, I believe, is a patron of the Santa Fe Institute. Right? He lives just up the road in New Mexico, which means he's sort of had these ideas in his head for a fairly long time, I assume. I guess the phrase is, it's not paranoia if they really are out to get you, So, yeah, hopefully that answers that.
Sorry, that's all we've got time for, but James will be available outside after the talk if you'd like to ask him any more questions. So would you please thank James once again.